Hi, this is Chris Olson from the ArduPilot organization, and this is the second video in the video series on how to set up a helicopter with the ArduPilot flight stack. In the first video, we looked at what the parameters are, where to find them, and what they do. In this video, we're going to look at the mechanical setup of the head and tail servos. To make sure that we have the limits and the collective pitch and cyclic pitch range set right. So before we get started with this, again, I'm recording on the Android tablet with Q ground control here. And well, before we look at anything more there, I'm going to look at the helicopter with a GoPro camera. I think the GoPro will work all right. It has a nice sharp image and everything. So we're going to go to the helicopter here and look at some things we're doing for setup. Let's step back here a little bit. The first thing you'll notice is that I have some shims underneath the landing gear. And this is to level the helicopter so that we can get proper readings with our pitch gauge when we put the pitch gauge on the main rotor. This particular helicopter has the main shaft slightly tilted forward in it, and when we talk about leveling the helicopter, we're talking about the main shaft. The main shaft must be perpendicular. So the way I do this is I take my digital pitch gauge, and this might be kind of hard to do holding the camera and the pitch gauge at the same time, but I put my pitch gauge on the main bearing block, on the top main bearing block, and you can see that we have 0 degrees of pitch as far as the main rotor is concerned, or the main shaft is concerned, and we have 0 degrees of roll as far as the main rotor is concerned, or the main shaft is concerned. And this will prevent problems with having to zero your pitch gauge and you know, doing some calculations due to the frame angle or the main shaft angle being different than what the pitch gauge is showing for the pitch angle. The second thing that I'm going to recommend doing before you start is to disconnect the rudder linkage. You can disconnect it here at the bell crank on the tail gearbox, or you can disconnect it up at the servo. The servo on this helicopter is buried way up inside the frame, very hard to get at. So disconnect the rudder linkage, and if it is a piston engine helicopter, which this one happens to be, also disconnect your throttle linkage from the carburetor before you start. This will prevent binding of those servos before we set the limits, and help hopefully prevent burning your servo out because it bound up when the system was moving servos to their min and max values. Going back to the ground station here, forgive me here, I'm working with both a GoPro recording on that and on the screen on the tablet. Let's look at the servo settings. For servos 1, 2, and 3, actually servo 4 as well, set the min and max values on all 4 of those servos, 1, 2, 3, and 4, to 2000 PWM and 1000 PWM for max and min. Set the trim values to 1500 for all 4. Now, let's look at servo directions before we start. And we'll have to switch back to the GoPro here to see what's going on. You'll see that servo 1, this particular helicopter has already been set up. So we're going to modify some settings here to show you what happens. Let's take servo 2 reversed, which is normal direction. And let's reverse that particular servo by making this setting right here. Now, I'm going to bring the RC radio over here. We're going to go back to the GoPro to see what's going on. And you'll see that when I move my collective pitch, I'm moving my collective pitch up to the top and down to the bottom. You'll see that the swash plate is not responding correctly. And that's because we have that number 2 servo reversed. This servo, the right front servo, is reversed, so it's moving the wrong direction. So it's important to make sure that those servos are set in the correct direction so that when you move the collective pitch, they all go up and they all come down when you move the lever in that respective direction. So we're going to set this servo 2 reverse back to normal and save it. And now when we look at the swash plate, you can see that when I move the collective pitch up, the swash plate goes up. When I move it down, it comes down. You may have to reverse 1 servo, 2 servos. You may have to reverse all 3 of them. It depends on the mechanical setup of your servos and linkages, which way the servos are oriented in the frame, and so on. But you have to set the reverse or normal direction on those servos accordingly in the software to get that collective pitch to go in the correct direction. On the tail servo, it's also important to set the forward and reverse on it. When you move the rudder, like when you add right yaw, you have to make sure that the servo is moving the tail pitch assembly in the right direction so that the helicopter will yaw in the correct direction. That's very important, because if you have that reversed, not only will the ArduPilot correct in the wrong direction, your radio is also going to be operating in the wrong direction when you use your rudder stick. So there again, make sure that the servo 4 is also going in the correct direction before you proceed. Now that we have the PWM, the trim set to 1500 on all 4 of those servos, let's go back to our H params and take a look here. The parameters we're going to be setting initially are H-cal max, H-cal mid, and H-cal min. We're going to start with the mid. And I'm also going to recommend setting this one to 1500 to start with. We will change that right now. And now when you look at your servos, after setting the servo manual to the mid collective position, that should move all your servos to 1500 PWM. So when we look at the helicopter here, with these settings being made, what you want to see is your servo horn being at 90 degrees to the case of the servo on all 3 units. They all should be identical. If they are not, pull that servo horn off from the servo shaft and put it back on there so that that horn is at 90 degrees. You have a 90 degree orientation to the servo case. This is important to get the same travel on all 3 links when you operate your collective pitch. You can see that they travel in an arc, and if they're in different positions, the amount of travel that you get from all 3 servos is not going to be the same. So that's important to make sure that that orientation is correct. But we are at mid collective with all the servos at 1500 PWM, and the next step in the procedure is to level that swash plate. And there's basically 2 ways you can do this. You can make the settings in the software and just start moving servos around, but it's better to do it mechanically. There's two ways you can, or two tools you can use to level a swash plate. This is a common swash plate leveling tool, which requires you to take the head off of the main shaft and slide the tool over the shaft and rest it on the bosses on the or the ears on the swash plate. Or you can use a caliper like this and measure the distance between the ears on the swash plate and your top main bearing block. These are all CNC machine pieces, so they are very, very accurate. And you can measure the three bosses and level your swash plate with this caliper just as well as you can with one of these swash leveling tools without taking the head apart. And the best way to level that swash plate initially is to turn your swash turnbuckles or your links going from the servo to the swash plate. And on this particular helicopter, you can put a wrench on here and turn them and adjust them without taking them off. On some helicopters, you're going to have to remove the link from the ball and turn it a half a turn or a turn and put it back on. But you use your mechanical adjustments to level that swash plate initially. And you may not be able to get it perfect with the mechanical adjustments. You can measure it with your caliper or with your swash plate leveling tool. If you can't get it perfect, then go to the software and make some fine tweaks to the servo trims to perfectly level that swash plate. After the swash plate is leveled, hopefully you will have zero pitch at the point where you leveled it. But that's not always the case. We're going to put the pitch gauge on one of the main rotor blades here so we can take a look at it. Turn the pitch gauge on. Okay. Back to the GoPro here. You can see that with the H-cal min set at 1500 PWM, we ended up at just a little bit below zero pitch. It's showing about 0.3 to 0.5 negative pitch. So to correct that, we go back to the H-cal min setting, or excuse me, the H-cal mid setting, set that back to the 1510 where it was, and save it. And now we're at zero pitch at H-cal mid. And that's where you want to set that. Don't set that to hover pitch or anything else. Set that to zero pitch. Otherwise your collective yaw torque compensation is not going to work right. So that's going to get your swash plate level and get you zero pitch at the mid setting. The next one we're going to look at is the min setting. And the H-cal min on this particular helicopter is set to 1470. So let's go to our servo manual adjustment right here and set that to the min collective and save it. Now going back to our digital pitch gauge, we should have approximately 2.5 degrees of negative pitch. For negative pitch range, I recommend 2.5 to 3 degrees for a typical UAV setup. And if you're going to be flying a 3D type setup, then you'll probably want to go to about -8 on the negative pitch. And you can set H-cal min accordingly to adjust where you want that negative pitch to be. The same holds true with H-cal max. This is your maximum collective pitch. And we'll go to our servo manual setting, change it to max collective, and save it. Now on this particular helicopter, we should have approximately 11 degrees positive pitch. It's showing 10.8, 10.9, 11 degrees. For the maximum positive pitch setting, If your helicopter is maybe a little bit underpowered, you probably want to limit that to about 10 so you don't run out of power. For a quite powerful helicopter, you can go up to 11 or 12 degrees with no problem at all. The next settings we're going to make, so to recap what we did here, using the servo manual setting, which bypasses the PID loop and gives you positive control of the servo positions without the RC radio in the picture, we set our mid pitch to 0, our min pitch in this case to minus 2.5, and our max pitch to about 11. So we have a maximum pitch range of 12.5 degrees from mid to max, and mid is at 0 pitch. Now we're going to go back to our let's see, we're gonna set the stabilize collective curve. So we're gonna go back and turn on the PID loop by disabling the manual setting again. Now the PID loop is active and control has been returned to the RC radio. I'm switching back and forth between radio and GoPro and the tablet here, so you'll have to bear with me. We're going to look at the IM stab call settings. I'll get rid of these other ones. Okay, these 4 settings, IM stab call 1, 2, 3, and 4, set a pitch curve for your stabilized flight mode. And call 1, let's say that you have a 3D setup where you just set up minus 8 degrees of collective pitch for acro, but in stabilize, you don't quite want that much negative pitch. So let's say you want to limit it to the 2.5 degrees where I set it at. You can set this setting with call 1 to limit the bottom end of that collective pitch range for stabilized flight mode, so the helicopter is not quite so hard to fly. Same holds true with stab call 4. You can limit that. You know, in this case, I've got 11 degrees of pitch. Let's say you wanted to limit it to 8 degrees of pitch. In stabilize, I could maybe set that down to 900, and it would limit it to 8 degrees of pitch. In this case, I chose to use the full collective pitch range in stabilized flight mode that is available in any other flight mode. I set 1 to 0 and 4 to 1000. The middle 2 settings, stab call 2 and stab call 3, set where the helicopter is going to hover at mid-stick and stabilize. So, on your RC radio, move your collective lever to the center position in the radio and take a look at what you have for pitch. In this case, we have 5.5 degrees, and that happens to be where this helicopter hovers in stabilized flight mode, or actually where it hovers at its minimum takeoff weight when it's full of fuel, which is full of fuel and no payload. So I set it to that, 5.5 degrees. Just to show you what this does, let's take this one here and set it to say 400. And save it. Now you can see that just by changing that one setting, it changed my collective pitch to 4.5 degrees with the stick at midway on the radio. So that is how you set stab call 2 and stab call 3 to get your helicopter to hover at mid-stick in stabilized flight mode. We'll set this back to 550. And it's going to say that it doesn't like that, so we're going to force this. It says it's dangerous, which it's not. I don't know who thought this up, but somebody thought up a range of 0 to 500 for stab call 2, and in this case we're going to use 550, which is outside the range, so the software says that's dangerous, but it's not. So anyway, now we're back Now we're back to our 5.5 degrees of collective pitch with the stick in the middle in stabilized flight mode. This is kind of an important setting because when you switch to any of the altitude controlled flight modes, the position of your collective stick can change, and it likes to be in the center for any of those altitude controlled flight modes. So if you don't have this set right, and say your collective lever is down a ways, and then you switch to an altitude controlled flight mode, suddenly you're going to get a big drop in collective pitch, and the helicopter is going to lunge for the ground. So having that set to approximately what you think your hover collective pitch is for the first flight is pretty important, and then from there you can fine tune it. And the closer you set these two together, stab call 2 and stab call 3, say if I set the difference between those two right now is 600, so it's obviously hovering at about 60% of the collective pitch range. If you set this one to say 575 and this one to 625, it will flatten that curve right around mid stick, so that it takes more stick movement to make a collective pitch change right there. So how close you have these set together determines how flat your pitch curve is in stabilized flight mode. So that basically covers the pitch for stabilize. Now we're going to go back to our H params. And on the manual, we're going to go to the pass-through mode. We are now in pass-through. So the PID loop is disabled. We have direct control from the RC radio, and we're going to set our cyclic range, which is H-cyc max. And to do this, going back to the GoPro here. To do this, move your collective lever on your radio until you get precisely 0 pitch. There's pretty close to 0 pitch. Now move your cyclic lever through kind of a circle and find the point where you get the maximum reading. Right there, it looked like we could get about 9 to 9.1 degrees of cyclic pitch. And you can change that. Let's just change it for you once. Let's change it to, say, 35. Show you what it does. We're still at approximately 0 pitch. Now let's move the cyclic. Now we can achieve up to about 12.5 degrees of cyclic pitch, which is way too much. Typically you want that to be around 8 to 9 degrees. So we're going to set that back to 25, which seems to work well on this helicopter. So the cyclic max, I believe what that does is set the actual tilt angle of the swash plate. I think that's what that 25 degrees refers to. And let's see, what was I going to mention here about that? Oh, in Mission Planner, this is going to be shown in centi-degrees, so it's probably going to show 2500 instead of 25. So there's a little bit of difference here in ground station software. This software is quite nice. It shows it in the actual degrees and, you know, the terms that most people understand. But you do this in Mission Planner, and I know that it's going to show that in centi-degrees, so that value will be 2500 if you're doing this with Mission Planner. Now we have to deal with the rudder servo, and we're going to leave the system in the pass-through for the radio control. And let's see, I'm going to move my RC radio down to the other end here so I can kind of show you the rudder. When you're in the pass-through mode, you can move the rudder very fast, like so. And if you move your rudder stick all the way one way, or all the way the other way, it will go to the limit set by the servo min-max for servo number 4. So if you move that rudder stick all the way that one way, and move your bell crank by hand to max out the travel in the tail pitch assembly, with that rudder stick held all the one way, see if this link is going to go back on that ball or not. And if it's either short or long, adjust your servo min-max until it fits in both directions with the rudder stick left and right. And that's how you can set your min-max without binding it and without bottoming your servo out and causing damage to your servo. And those settings are made. We'll just look at them. We'll just look at them quickly. Again, bear with me. I'm going between GoPro and radio and tablet here. Let's look at this quickly. Go to the servo settings. Servo 4, which is right here. In this particular case, I have my min set to 1250, max set to 1800. And when you're in the pass-through mode on the SV MAM, those values right there will set the limit on that servo so that your linkage fits without binding it. Servo 4 max and servo 4 min. Okay. Just looking at my outline here, that about covers the basic head setup and the tail servo setup. There is one more setting that we can use to check our final setup when we're all done. Let's go back to our H settings. Servo man is on pass-through right now, and it doesn't show this as an option in Q ground control. So go to advanced settings, manual entry, and let's set this to 5. And save it. Okay. Now with the GoPro here, watching what it's doing, it continually cycles the servos through the limits you have just set. So you can make a visual check of the swash plate and the linkages to make sure nothing is binding and you have the full travel that you set. Same on the tail. You watch your tail slider. You see that it works quite nicely without binding or anything. And by setting that to 5, it will continually keep cycling it so that you can visually make a check of your settings that you just made. Kind of a nice feature built into the software. So to end that, we will go back to disabled. And the PID loop is now active again. And we're in stabilized flight mode, and we have normal control with the RC radio in stabilized flight mode. So there, that about covers the setup for the head, pitch ranges, and the tail. So you don't bind your servo on the tail before you get your ranges set for the tail. And the next video we're going to be looking at is how to set up the rotor speed control system. And that is a little bit more involved. There's 3 different modes and so on. We'll cover that when we do that video, I guess. Thanks for watching. We'll be back with video 3.